now we're at the top of the hour, and I would like to welcome everyone for joining the webinar. And it is now 9 o'clock. And thank you for joining us. This is now joining us for some of us out there that are joining us with coffee, lunch, maybe second lunch or afternoon tea, and maybe dinner. Today we are joined by probably people all around the world today, which is really cool. It's loving to I love seeing the attendance list and seeing people joining from all corners of the planet, and which is amazing. And so, but yes, we're going to be talking about designing networks for and utilizing external antennas. And before we get into kind of some introductions, wanted to just kind of lay out a couple of housekeeping items that we've got today. For those of you that are looking to get some Q&A to our panelists and our guests today, please do utilize the Q&A window. We will be answering those questions as best we can, and we're going to try and answer those questions live right away. So as we get them through, we're going to do our best to answer those live and get out some of those questions during and towards the end of the webinar. And if there's some chatting, which is always usually open, keep your chat in the chat window. Try not to put the questions in the chat window because you can't really see them all the time. There's a lot of chatter. So
I will say too, Stu, just really quickly,
yeah.
I will say too, sometimes there's a lot of questions that come in and we miss them, but don't worry, we do download the transcript so we can make sure that no questions fall through the cracks after the fact. So if we don't get to your question today, we will definitely make sure it's followed up and answered for you. So just to clarify also, I mean, just to add.
Yes, no, that is a very good point. We don't forget about those questions we know that you've asked. So that's really good. That's a really good note, Tony. So folks, we are going to be doing designing networks utilizing external antenna APs. This is a really key thing, and I'm really glad to be joined today with, of course, the fabulous Tony. And also two dear friends of ours, both of ours, Jake Snyder. And if I could flip the screen here, there we go. Jake Snyder, who's coming to us live from Boise, Idaho, and Steve McKim, who's coming to us all the way from Rossburn, Manitoba. And so that is in Canada. So he's one of my fellow Canadians, fellow Canucks. And Steve, Steve and Jake, this is your first time on a webinar.
Very first on an Ekahau webinar.
That's right.
Yeah.
Very welcome. We're so excited to have you guys.
Yes, very excited. So, awesome. Gents, we love external antennas, and I mean, I love them too. I mean, antennas are probably, one of the kind of things that I've seen is that people are always kind of like, should we use them? Should we not? Like, oh, we'll just be fine with an internal Omni. That'll work, right? It's good enough. But I love external antennas. But what about you guys? I mean, you guys must love or come into to the same questions from customers, right? They say, well, should I plan for an external antenna or should I just leave it the way it is? I mean, how do you address that sort of thing?
Well, I'll kick it off. For me, it comes down to like the things you're trying to achieve. If your requirements are fairly low, and the things you're expecting out of your wireless network are low, integrated Omni antennas are great. They're easy to deploy, but if you start asking more and more out of your wireless network, when you start increasing the density of access points and users in a physical space, suddenly controlling where that RF goes is just super critical to being able to ramp up, being able to do more. And so that's where external antenna APs come in. It also gives us a tremendous amount of flexibility in terms of picking the right antenna for the right, environment. And as you want Wi-Fi to get better and better, the tools that come down to that are typically are RF related, and that comes down to antennas.
Yeah, I agree. I mean, it's always comes down to the network requirements and knowing all the tools you have available to you to meet those requirements. You know, antennas are not only a good way to focus the RF where you want it, but to reduce the noise that you have coming from other directions. So I think that's always something to remember. They work both ways.
So I mean that's really good. I mean, we talk about like defining those requirements, right? Trying to figure out is do I need them or not, right? It's whether it's internal or external. What should we look at? I think is maybe it's like when you look at the internal antenna design. What do you? For me, I see it as, you know, I always look at the pattern, see for what am I going to do, but you know, you guys talk about how do you go about? I mean, you know, making that decision sometimes.
And go ahead,
Sorry,
Steve.
go ahead, Dick. Well, I mean, you got to look at floor plans, layout of clients, how they're going to be in the space, and then again, how dense your network is, like Jake mentioned, and how many APs you're going to have, how much noise. I always, obviously, like I said, external antennas or directional antennas are going to put the RF where you want it, but they help to reduce your CCI coming from your network and other networks. I mean, you always look at the pattern, like you said, Stu. And, you know, I started in wireless ISP before I really got into Wi-Fi, so I kind of have gotten good at seeing an antenna pattern, how it's going to go in front of me. If I'm standing, say, up in the ceiling tile or, you know, doing a physical site survey, I can get a good idea of what that coverage is going to look like just in my head. And I think the internal antenna patterns, most of them have changed from that standard donut lately to more of a lot more down tilt built in. So they almost look like more of a bowl shape. So that you can focus them a little bit there, but they still have the limitations, right? They're still an omnidirectional antenna.
And my kind of take is that, you know, when you're trying to provide coverage, omnidirectionals are great. They spray RF, you know, everywhere in their pattern, and which is typically 360, you know, horizontally. And depending on the gain, they're going to have either more. It's either going to be tighter, so just closer to the access point, or it's going to be like like Steve said, a down tilt where it's just directly kind of under that AP. And that can help, but it's still pretty wide compared to what we can get into some other antennas. The other caveat there is that certain antennas lead themselves well to externals because of space. You know, if you look at the shapes and size of some of these antennas, some of them are larger than the access points themselves, and because of that, you're kind of constrained into what you can do with an integrated antenna AP. So.
Yeah, and I think too, just really quickly to highlight, it's not that we're saying internal antenna access points are bad or anything like that, but there's a time and a place for everything. And as Jake was talking about, an omnidirectional pattern does spray everywhere, and sometimes you do need that fixed directional coverage, specifically like warehouses or some, you know, other challenging environments that you have to use an antenna for, just because specifically you're trying to make sure you have the coverage. So
I often kind of relate it back to lighting, right? So, right, lighting is RF. Why don't we just use like, you know, like lamps everywhere, right? Because it doesn't necessarily do everything that we want. And so we're going to have some overhead kind of spotlights or floodlights. We're going to have some overhead, you know, just can lights. We're going to have some fill-in lamps. We're going to have, you know, all kinds of different lighting to achieve different effects. And just like that in Wi-Fi, you know, we wouldn't just use a lamp everywhere. That omnidirectional, you know, send Wi-Fi everywhere kind of deployment. It's often, you know, what kind of effect do we want? That's not to say that there isn't some personal preference and styles. And there's also a lot of things that people forget about when it comes to RF design, which is logistical, you know, the logistics of putting these in. fewer parts, fewer part counts. It's easier for a lower capability person, like say a cabling technician, to be able to put an AP in and not have to worry about necessarily the nuance of directional antennas or mounting or those types of things. Physical installation is easier, and typically today I would say they somewhat look better. So.
Well, the internals do look pretty aesthetically pleasing.
They are
at times, right? I mean,
it's
they're
clean,
looking pretty
sleek.
fancy. I mean, there's a lot of internals that are looking fancy. I mean, I know some APs, they are using, design teams that design cars, fancy cars, which is really cool, right?
I've heard manufacturers go on at length about the shadow that an AP may or may not cast on the ceiling, and it's like
Yes.
aesthetics are a huge part of it. And
form factor.
They are. Yes, sleek form factor, or I want it to be so sleek that it just blends in with the ceiling, right?
Yeah.
And that's where you can use enclosures to kind of help along with that. So when we look at between internal and external, right? We know that what an internal is going to do, and when it's fixed, we know what it's going to be doing. But when we talk about external antennas, right? What do we need to know? I mean, we know that, okay, those ones are going to be in those challenging environments, right? Or those concentrated, right? I mean, even just looking at the picture there, we see that it's more of a a design that maybe the antenna may be pointed out is to cover a specific area, right? Whether you're focusing on it, right? Because I think this is where, and there's a great question in the queue here, which we can line up here, but is how we're doing mounting, how those APs are going to be mounted, are we doing to increase density, right? There's one great question here from Sam, and I got to get to it because it's burning on me here. It says, what advice would you have for Wi-Fi designers concerned about using directional antennas to get coverage into a specific area, but are worried that the client won't be able to talk back to the AP?
That's a great question, Sam. Always remember that the antenna is reciprocal, right? You're gonna not only increase your radiated power from the access point, but you're getting the gain on the received signal from the client as well. So it works both ways, and it's gonna benefit both directions of traffic equally.
You mean like reciprocity? Like, is that what we're trying to say, Steve?
Gotcha. Yeah, that's the word.
Gotcha. Yeah. Awesome. Absolutely.
The other piece I would say on Sam's point, what advice is, antennas are, because they're reciprocal, we can kind of exclude them from a lot of the things that we're talking about, but you still have to keep things in mind that if you're operating your access point at higher power than, say, the client's capable of, there can be some, I'm not saying they have to be balanced, but you can definitely get to a place where an AP can transmit to a distance where a client can hear it, but not necessarily the reciprocal. So we still have to kind of stay within reason in terms of transmit power with directional antennas.
Yeah, absolutely. Stu.
Yeah.
Question for you. Folks are asking about different antenna vendors. I mean, there's a lot out there. What would you give advice for folks who don't know anything about antennas or where to get them? What would you recommend them to go to get information about antenna vendors and pricing and some of those kinds of things?
That's a great question. There are a number of great vendors out there. And there's, we've got folks that, of course, the manufactured vendors. So, Cisco and Aruba and Mist, they all have their own, and I believe Mist does, but they all have their own actual branded antenna, which are great. And then they also get your more specific or, more in detailed antenna to meet your needs, done by the folks at Ventive and Exceltex, PCTEL, and I might be missing another one. If any of you gents could figure that out. So there's those are the three ones that I know of right away that we could say. Yeah, those are um, kind of going and understanding, what each of those antenna vendors has to offer to meet your design requirements.
Jake and Steve, let's start with Jake. Your thought. I mean, OEM versus third-party antennas. What typically do you find yourself doing more of?
Honestly, I think I do more third party than OEM. It depends on the manufacturer as well. Like some of the manufacturers are a little limited in the types of antennas that they offer. So they might offer a directional that's maybe 60 degrees, but they might not offer something that's, say, 30 degrees, or they might not offer something a lot wider like 120 degrees. So I find that the third party gives you a little bit more of a something closer to what you're after. But that said, a lot of folks like to buy the first party antennas simply because, well, I'm writing a PO to vendor A. It's easier for me to just include all of the bits and bobs for make one PO instead of making maybe 2 or 3. So, but like I said, I like the flexibility in having a couple third-party manufacturers that I can pick from, and when and often they're doing innovative stuff. And so it's like, hey, I have this one use case where maybe there's only one manufacturer that makes that antenna, or an antenna that meets that requirement. So it opens up a lot of options where you can get into some more ideal designs. But at the same time, I also recommend kind of picking 1 or 2 per deployment. And like you shouldn't go into like a deployment and have 15 different antennas. It's just not practical. So find something that meets. I know. I think Mitch Dickey has a term. He's like the everyman antenna that he loves, and he puts it in a lot of places. Finding those antennas that are pretty flexible and diverse that you can put in a lot of places to keep your part count down.
Awesome. And folks, we're getting a lot of questions about deployments in warehouses and tips and tricks and using directionals in outdoor stadiums. We're going to talk about some use cases here in a little bit. But first, we're going to specifically talk about the different types of antennas. And so one of the questions that I had, Steve, I'll pose this to you. We just talked about the internal antenna APs having the omnidirectional pattern, and now we're talking about external omni antennas. What is the use case? And talk to us about the omnidirectional antennas, external antennas, utilizing.
Sure. Yeah, so the external omni is generally going to be a higher gain. And you can see from the slide here, generally, if you go higher gain, you're just squishing that donut, right? So you have a much narrower vertical pattern. So you're going to get more distance out of it, more gain horizontally, but not so much of the vertical beam width. So you might go from a low gain antenna with a, say, 90-degree vertical beam width on an omni. Well, that's quite a lot, but to a higher gain one down in the neighborhood of, say, 15 or 20 degrees vertically. In the wireless ISP space, you might get an omni that's a 15 or 17 degree omni that has a 2 or 3 degree vertical beam width. So that's what you're looking at.
Awesome. Okay, so omni, any other kind of antennas? Do maybe a directional antenna we can talk about today?
We sure could. Yeah.
Absolutely. These are actually probably one of my favorite, to be honest. I think that and antennas that are like we'll get into in a bit, is the monopole type antennas, which are actually quite interesting. Is in terms of, it's not much more directional, but Jake, you and I talked about this a while back, trying to using monopole type antennas to get a better down tilt on focused areas. And where you can actually, instead of using this regular dipole one, but then using a monopole to get a better
yeah, so monopoles are they fit in the like omnidirectional category, but monopoles are kind of nice in the fact that they use something as a ground plane, and that ground plane actually kind of gives them a shape where it's a little more, some might call it down tilt, but it's a little more skewed the direction away from the thing that they're connected to. So
yeah, I have
and that
one
gives
actually right here on a camera. So it's a very small, looking antenna, but that's the kind of the size of it right there.
And they give you kind of a traditional rubber duck is more that kind of or dipole antenna is more of that traditional kind of donut shaped looking thing. And so a lot of times if you don't necessarily want that kind of donut shaped, especially with the hole in the center, that can be a problem for people directly under an antenna. Monopoles can sometimes give you a little bit of a gain or a kind of fill that hole in so that you're not.
You don't get into that cone of silence, right?
Yep.
Exactly. That cone of silence. And that's where it comes into the directional, right? Is those patch antennas. Those are great for getting down those corridors. What would you guys say? What would you guys say the kind of good use cases for are trying to make sure to take advantage of patch antennas? Maybe that wouldn't apply to maybe down an aisleway or something.
I'm a huge fan of just in dense open offices. One of the we were having this conversation this morning with some friends is that if you put an Omni or even just an integrated antenna AP in a room, it's going to fill that room, and the delta between like if you put multiples in a room, let's say you have 4, they're both going to fill that. They're all going to fill that room, and it becomes very difficult for clients to pick which AP is closest because there's so little difference between which AP I'm looking at. And so directionals give you the this effect of the thing I'm directly under is really strong, and the thing further away is much weaker. That ramp between good and bad is a lot more exaggerated in a directional, and therefore if you point it down, just mount it on the ceiling, point it straight down, it makes it a lot easier for a client to pick the thing it should be connected to.
And I think in the next slide we'll see that is talking about that type of scenario. But just to kind of to touch on this slide here is when we talk about a lot of people don't use patches are very familiar, but the panel and the Yagis, the Yagis are probably one of the in my I guess the oldest type of antenna, but that's a more kind of a high gain. I'm going to just point it right down like across if I'm going to do like a site to site or outdoor. Is that something that you still see today? I mean, I don't know, Steve, do you still see like using those type of those high gains out in, connecting, doing wireless shots?
Not so much Yagis, maybe more in like the 900 megahertz is where I would see Yagi. 2.4 I don't really see for building to building. It's more 5 gigahertz where you'd be using. I don't like the panels. I prefer to go with a dish, a small dish even.
Oh, really? Okay.
Kind of thing. But that said, if I'm linking to buildings or across a farmyard or a manufacturing yard or something, I'm usually using a product that's made for point-to-point bridging. I'm not going with a 802.11 specific type product, if that makes sense.
Yeah. So on the dish part there, you're finding that it's a more of a focus, just like the nice fancy colored picture on the on the slide, right? It's a very focused.
Yeah, exactly. I find you get a little better performance, a little better front to back ratios. You still have your side lobes on it, but size wise, you get about a 23 dBi dish in 5 gigahertz is about 18 inches. So it's not huge. Obviously, the bigger you go, the more gain and the more focus you get out of it. But then if it's a really short shot, I would usually look at a even higher frequency, say 24 gigahertz or 60 gig, but that's kind of beyond the scope of this webinar, I suppose.
Yeah, well, yeah, no. But this is all really great content, right? I mean, it's we talking about selecting that right antenna and those use cases, right? And we talk about okay, this is the great one. This warehouse scenario, everyone's this is one of the most exciting ones. I think,
we're getting a lot of questions about warehouses specifically.
A lot, and so to all those folks that got in the Q&A there, it's we're now up to your favorite topic, the warehouse.
So I spend a lot of time in warehousing in terms of designing and deploying And I've seen a lot of very terrible warehouse Wi-Fi. It's also one of these environments that's really tough from a just an environmental perspective. There's lots of metal, lots of multipath, and one of the things that has, we've seen kind of the evolution of this go from, omnis were a big thing probably a decade ago, and everyone just had omnis, and then we saw high gain omnis. We saw that one that can shaped looking, higher gain omnidirectional, and the thing to remember about that is trying to put RF where you want it. And the higher the gain those antennas are, the more narrow vertically that their horizontal, their vertical beam width is. And so the Wi-Fi was terrific 40 feet in the air, but it wasn't so great down below because the gain down below the antenna was actually fairly low. And so this is where, I think most folks have kind of moved to a directional, either straight down pointing or shooting down the aisle. My preference is always a directional antenna pointing down. And the reason for that is because there's never a point where I'm shooting through an aisle, like or through a shelf of equipment. I'm never trying to shoot past stuff. So like if somebody stacks a bunch of, and this actually happened to me, somebody stacked a bunch of metal empty containers all the way to the ceiling, and the directional antenna was on one side and they were trying to pick product on the other side. It didn't work. And so I like the overhead directionals pointing down. In fact, there's a number of manufacturers now that make a very narrow aisle width antenna that goes very wide in the other direction. And it keeps it so you're never trying to shoot through stuff or shoot the kind of the wrong way. Omnis are very dependent on load. So like if those shelves are really empty, it may work great. If they're full, it may not work so great. And then finally, one thing that people often forget about in warehousing is we still have, like, it's pretty rare I walk into a warehouse and I see modern clients. In fact, I walked into one a few weeks ago where they still had 11B devices. And one of the
That's still
things that
very common.
one things people forget is like, well, oh, multipath was a big deal back then. It's not as much today in 11AC and Wi-Fi 6 networks, but for those old devices, multipath is still a big issue. And one of the things that they didn't deal well with in like B and G was what we call delay spread. And delay spread is the amount of time that it takes for the first signal, the most direct path of signal for that, from that AP to that client to get there. And then so many milliseconds later, you get an echo of that as it bounced off the ceiling and 6 aisles, and it went through an HVAC vent and came out. And that distance in time, they had a hard time differentiating between what was the original signal and what became basically destructive interference. And so when we talk about omnis and we talk about spraying RF in all directions, that amount of time it takes for the first signal to the last signal becomes longer and longer, and it starts impacting that performance. Directional antennas kind of tighten that up because I'm only sending RF energy in one direction. There's less reflections, there's less multipath, and consequently that delay spread shrinks to the point where those old clients actually deal well with it. So I'm like you see in the upper right hand corner, there's that kind of like a loading dock. A lot of folks would look at that and say we should do omnidirectionals. It's a big open space, but I'm still in the directional camp. Now maybe it's not as tight, but do I really care about RF energy going up? Nope. Do I really care about RF energy going side to side? Nope. 40 feet in the air, you're not gonna do anything with that. But a moderately wide patch, like a patch that's, let's say, 90 degrees, 40 feet in the air, definitely has a lot of properties that are going to look more like an omnidirectional from the ground perspective. So taking a look and saying, well, maybe I don't use a super narrow patch like a 30 degree, but maybe I'm a 90 to 105 degree patch. Keep that RF energy going the direction you want it, and still cover a pretty healthy wide area.
Yeah, and that's where your tool like Ekahau lets you see what that cell size looks like, rather than having to do a bunch of trigonometry going, my antenna is at 40 feet and theta is 90 degrees, etc. Sine of whatever. Plop her
So
in and you can vary the height and see what it looks like.
and the other piece is that people often forget, and I love like taking this and throwing them into to Ekahau and actually modeling it up, because people, when you say it's a 30-degree directional or it's a 60-degree directional, people think it stops after 60 degrees, and in reality it doesn't.
No, it doesn't.
Yeah,
Turns
and you
out
need to pay
like,
attention to whether that's the 3 dB or 6 dB
yep.
down
So
point, right? Because that makes a big difference.
Yep.
yeah, so most antennas, they rate, not all, but most, they rate beam width is in terms of 3 dB from peak. And so when you say, like a common one is a 6 dB patch antenna. Well, when I say it's 3 dB from peak, that really means 3 dB, which is often what you would see like an integrated antenna having from, like an integrated antenna AP. Well, at 60 degrees, I'm back to where I would have been if I'd used an integrated antenna AP. So it doesn't just stop at that mark. It just means that, that's where I get that 60 degrees from. And as you ratchet out further and further, it's going to drop off quicker. But knowing, like, some antennas have a really sharp drop off and some have a very gradual drop off. And that's where looking at the antenna patterns and saying, oh, well, I've looked here and that antenna pattern, doesn't stop at 60. Like, you can still see there's a line. It doesn't shrink back to the center like it does in like the one on the left. And so those are things that you look at and say, well, even though I'm using a 60 and that 60 at 40 feet is going to be, X, feet wide, you're still going to get signal well beyond that that's going to be usable. The only thing I would caution folks is people start getting crazy with high gain directional antennas in warehouses, and they forget that there's still like 40 feet's a good distance. You get beyond 40 feet, you get 50, 60, 70 feet, and you start getting your butt kicked by regulatory bodies. Meaning, like, if you're in the US, the FCC is going to cap how much transmit power you can use. And so it's not linear, right? So you get up there, they may start saying, well, you can't transmit as loud because of all this gain. And now suddenly you're like, well, I was planning on using, a 13 dB antenna with 20 dB of transmit power, and suddenly it's like, no, you can only use 15 because the FCC is limits that. And so you do have to make sure that either your manufacturer supports the antenna gain you're using, or that you're still within regulatory compliance, right?
Yeah, and that's where knowing your antennas comes into your network design as a whole, right? Because you also have to think about what channels you're going to use in the network. Are you going to use everything, Uni 1, Uni 2, DFS? Like, there's different regulatory limits for the different bands. So like you said, you're going to use a 13 dB patch. Well, your EIRP, your max EIRP is much higher in Uni 3 than it is in Uni 2 or Uni 1, at least in Canada. So plan your power levels accordingly, plan your antennas accordingly.
Yeah, absolutely. Awesome. Warehouses, I think, is one of the challenging environments that people always have questions. What happens, Jake, if you've got an AP down an aisle that goes down? What do you do in that regard, right? There's just a lot of questions surrounding that. And I think that it's important for everybody to remember it's an art, and everyone does things a little different too, I think, as well. And every environment is obviously very different as well. So
absolutely. I mean, even if you have an aisleways that are, let's say they're full of liquid, right? So we know that, okay, in a brewery, right? So maybe or a winery, and then they'll stack stuff. They'll stack bottles. They'll stack everything. They'll stack containers, vats of liquid, whatever it could be. In, like, just imagine those boxes there. They could be full of wine, right? And that makes a considerable amount of difference, because the water is going to create its big attenuation right there, right? It's okay, that's just going to be a little bit harder for it to travel through. So that's when you have to get creative in your designs, and then know that, okay, is this always going to be like this? or is it going to be like a one of those huge warehouses where we all shop and buy everything at, which their aisles change all the time? And is it designed for that type of warehouse, right?
Or cyclical too, because oftentimes, like back to school promotions, what if it's retail that's like that? They bring in a lot of inventory for Christmas or back to school. And so understanding the ebb and flow within a warehouse cycle in and of itself. So sometimes you have a full warehouse, sometimes you don't. So that can also impact design. Yeah. Awesome. Let's talk about, I know we have a lot more examples and we have a lot of questions in regard to that, but don't worry folks, we'll definitely get to all the questions.
And I think we've been covering some of those, just going through the questions here. Yeah. I think we've been talking through them. Jake and Steve have pretty much identified a lot of those things, which is really good. So open offices, I mean, this has always been kind of, yes, you can try it out. What do you guys think? I mean, I've tried both. In some situations I've had to revert back, and some have gone forward with externals.
Yeah, I mean, open office is it's the bane of Wi-Fi that people want to do this. I think it's a terrible experience as an employee, but I think one of the the demands are space utilization. That's what they don't want to buy 10 office buildings when really the buildings are 20-30% utilized. They want to reduce the amount of real estate investment they're making and make that space more consumable. But I think one of the challenges I see is aesthetics is a big deal in open office, because they're trying to be very modern, forward-looking buildings. But again, density is really where the constraining factor. Like if you look at some of those pictures, that's a lot of people and a lot of devices in a very small space. And so depending on the use case, like if you have like creative content creators, that's a recipe for disaster with integrated antennas, simply because everyone's going to glom on to one AP. And it's very difficult. I have a personal motto. It's like, never do in software what you can do with good RF engineering. And the reason for that is like, well, yeah, there's things that, like load balancing and things like that, where we can try to force distribution of clients around, but some clients don't like it. Some clients don't behave the way we would expect. And therefore we end up with these suboptimal things. And so using those directional antennas in open office spaces really helps you constrain the area where that antenna looks, or that AP looks attractive to a client. And so now I get clients picking their closest AP naturally. We did an example this morning at Ekahau where they did omnis, and it was between the top 3 APs in this room, there was 2 dB of signal difference directly under one of the APs, 2. Now we swapped those same APs, same height, same everything to directionals, and it went from 2 dB to 22 dB.
What a difference.
And so there was 22 dB difference between the AP that I saw directly above me and the AP, 20 feet away. And that is where you start naturally load balancing those clients. Now,
that's a good use case.
The other piece is so, and the natural thing that starts happening is, folks are going to start saying, well, I need so many users per AP, right? Or so many devices per AP. To get my my magic math of how much throughput everyone needs to get. And if you throw omnis in there, you really don't have a lot of control in terms of how you pull that off. You're banking everything on that magic software algorithms that's going to fix everything. And unfortunately, I think it really comes down to those things try to make the best of a bad situation. Don't put them in the bad situation. Use RF, use antennas to shape where that RF goes. The other thing, is that using those directional antennas, I'm going to increase the SNR of all my clients by 3+ dB because I'm going to hear them better. They're going to hear me better. And so as you get through this, there's no scenario where an omnidirectional in a big open office is going to be, a better performing network than a directional. It just, there's not really a place where that happens. Now, that doesn't mean that you can't create coverage problems for yourself if you use too narrow of an antenna. Yeah, now suddenly, I used a 15-degree directional at 10 feet. That's not a real wide area that it's covering, and my APs are 50 feet apart. But typically, as you start ramping up the density of access points in a space, and the distance between those access points in that space starts decreasing, now we need just some way to differentiate between the AP above me and the AP next to me. It also helps with things like roaming. So I often see people throwing omnidirectionals or integrated antennas in, and they pick up their laptop, especially like on cutover night, right? There's nobody there, and they pick up their laptop and they walk over and stand under the next AP, and they look up and the light's still not showing anybody's connected. And they're like, why didn't I roam? And it's like, well, your laptop's still happy way back over there with the AP that you were on because it's blasting RF everywhere. If you'd use focused, more focused shaped cells, you roam much quicker. And so you start getting into places where that really starts performing and behaving like you would expect.
Well, and it also depends on the environment too, right? Because there's a lot of offices that may have, like there may be high ceiling type like that one on the top right, but it may have cable trays that are hanging down, right? And all of a sudden these cable trays are like 8 feet from the floor. And, and then you have to go, okay, well, you got a grid cable tray system just running open air space. And you're like, okay, now it's very difficult to kind of push that down because now you're dealing with this, this steel cable tray everywhere or aluminum cable tray. And then that's where you're going to go, oh, maybe I do have to go back to an Omni, or in some cases, maybe throw in some external monopoles or something like that, right? I find there's always a different case for everything, right? It's you always have to look at the situation and maybe approach it with a little bit more open mind.
Yeah, physics is a harsh mistress, and you can't beat physics at anything. You can just trade one thing for something else, and so often nothing in Wi-Fi is ideal. Obviously, we're going to have situations or materials, things like that, when I can't push through it. I got to put something on the other side of it, or and so part of that design process is trying to make the best decision you can given the constraints you have. And open offices, density is often one of the large constraining factors. Not the only one, because aesthetics are going to be like the architects going to come in and say, you can't put that ugly thing in my building, but
well, then and that leads us into the outdoor. It's like, sometimes we can't put, some we have design constraints even there on type of antennas, right? And absolutely. And was it Steve, you were mentioning earlier, is when you're doing outdoor scenario, is you've got to pay attention to your regulatory requirements, because now it's a little more different, right? We're now outside.
Yeah,
and your outdoor, I mean, you talk about DFS and indoor, I mean, that's a whole other can of worms. With DFS outdoor, certainly there's been instances where there was a picture floating around the internet a number of years ago. There was a weather radar map. And on that map, there was a very nicely defined antenna pattern where I believe it was a wireless ISP somewhere in the States, was running way outside of regulatory limits in a DFS band, and the weather radar was picking that up perfectly. And there was a number of things that happened to the equipment manufacturer that guy was using as a result of that. But and when you talk about aesthetics, I think one of the best things a network designer or network engineer could do is, if you're not familiar with what's available, just pick a vendor one day. If you have some spare time, jump on their website, go through their products. You're going to see antennas and mounts and various different ways of hiding your antennas. So if you're working on office space, outdoor, whatever, it's good to know about those things before you start to plan your network, because if you have your network planned and then someone goes, oh, I just heard about this, and changes a lot of things. But for your outdoor, in the chat, somebody made a comment about you can't always cover outdoor from indoor because of low E glass. I mean, yeah, especially depending on your climate, your windows might be triple pane, low E, argon filled, and those seriously attenuate RF. You wouldn't think you can see through it. Why doesn't the RF go through? But that unfortunately isn't the case. So externals in outdoor, generally speak, well, one of the reasons is going to be weatherproofing. There aren't really any, well, there are some, I suppose, indoor or internal antenna APs that are outdoor rated, your IP67 and what have you. You can use those with external antennas, but you got to put them in an enclosure. Your costs go up. Doesn't always look the nicest. So when we're talking outdoor, maybe it's a city park. You're not going, you maybe cabling becomes an issue. You probably don't want to run mesh. So I know Jake mentioned like distances in warehouses. If you've got a park that's 100 feet long and 100 feet wide, you might be able to cover the whole thing with a couple externals just at one end of that park. Still worrying about EIRP limits, obviously, but you're not having to trench cable through the park or run mesh. And other areas, festivals, obviously those are really dense areas, outdoor music festivals or that kind of thing. You're going to want to run directionals. That turns into the same kind of idea as, say, a stadium, right? You want to limit your cell size, limit your CCI. So a nice tight high density patch, something like that's going to work well there. And then you, again, the point to point and point to multi-point stuff. Point to point, you see people use omnis where there's just it is just a point to point, but they're running an omni. I mean, you're causing yourself and other people all kinds of grief like that, because not only are you spewing noise everywhere, you're picking up noise from everywhere. Whereas if you can tighten that up, I mean, it's only going to one spot, so why not use a much tighter antenna? I like to use antennas not only to increase signal level, but to decrease the noise that's coming in. It works, good advantage there for you.
So that's definitely
Awesome.
outdoors, a whole other, I think outdoor, that might be a good one to talk about in a whole other webinar. I mean, because you could really go on, like, I mean, in the total deployments. And I think there's one topic that, I know that that's you're close to on both sides of the fence here, Steve, is with outdoor planning is doing WISP service wireless shots between buildings or long distances. But and that would be a really great something to dive into. But and I know the next one that you're really close to is that K-12 region. I mean, that's something that, I mean, has its own design challenges, I would assume. I mean, I've spent some time in that as well, but you're in the thick of it, and it's and it must provide some really interesting design challenge based on probably the clients, the density, and I guess now it's probably you're becoming more dense now with
Isn't
devices.
the rule 1 AP per classroom? Isn't that the rule? Isn't that how that goes?
Is that really, is it happening now?
Totally joking. Totally joking.
Yeah, so K-12 is my day job. There's a number of struggles or problems we run into, from budget to old buildings, asbestos, etc. You may not be able to, so let's say a K-12 wants to do a refresh on their Wi-Fi. Their last refresh was 802.11n. Obviously, that's 2 generations behind now. So they want to deploy AX, but they either blow the budget on the APs or they blow the budget on recabling. All their old APs were in the hallway, so they can use that existing cabling, but their APs are in the hallway. Well, you can throw on some external directional antennas pointing from the hallway towards your classrooms. There you go. In terms of density, you're going to be able to keep your cell sizes to a classroom or 2. If you're looking at redundancy, I mean, redundancy in K-12 isn't super critical. Wi-Fi, at least in our division, isn't a mission critical service. That said, we are moving more and more towards more wireless devices, even teacher stations. Teachers want to be mobile in the classroom, so you're looking at a laptop or a tablet for them, rather than the desktop on their desk in the corner. In terms of 1 AP per classroom, we haven't seen a need. I know there are places that do. obviously when you get to that, unless your ceiling height in your classroom is, 30 or 40 feet, you're fine with just the internal one.
Mm-hmm.
Other places in K-12 you're going to want to use directionals would be a lecture hall, lecture theater, for reasons both
gymnasiums.
Yeah, and for ceiling height, specifically in a gym, right? Your ceiling's 30, 40 feet up in a gym, plus you've got your bleachers holding 200-300 people or more, depending on the size of your school.
Mm-hmm.
Oh, and in your lecture theater, you've probably got 100 students or more.
Mm-hmm.
Obviously, in higher ed, that just goes up exponentially, right? So.
Mm-hmm.
Your client density, is, as Jake has mentioned a number of times, is number one, and then keeping the RF where you want it. Those omnis up 40 feet aren't giving you the coverage that you want.
Well, absolutely, and I think that's why, not put the shameless plug in, but I mean, that's where leveraging the design tools, like in Echo Pro, where you can actually say, oh, hey, this is my area, this is the type of antenna from this manufacturer, right? You can say, I've got an Exceltex or a Ventive antenna, and I can say, okay, what are the differences between these two? How are they going to be able to focus that energy, and how's it going to work in the gymnasium at that height, right? Or how's it going to work in that particular area? And then and planning for client density, right? That's also important. Is can I meet those requirements? And I think the K-12 is always is like you say, it's you're always subject to a lot of older buildings, the structure, and budgetary, and you try to do the best you can. But I think it's going to start changing. And I think for me, and I can see, we're going to see more devices in a lot of K-12, and it's and I'm already seeing it here locally. More devices, and trying to plan for that, and trying to make sure you got the right design.
Yeah, certainly. And like there's no blueprint for K-12 everywhere. They're all different.
They're all different. Yeah.
The device count is definitely going up for sure.
It is, yeah, for sure. So I mean, we're getting close, and we talked about we don't want to talk ourselves out of using an antenna, right? I mean, we don't. Some people I think is that I always run into, and I'm sure you guys maybe can comment, is that I always run into the thing about, well, I don't know, what's it going to look like, right? Okay, well, let's look at it in ECHO. Let's see how that design is going to work out, and figure out is that going to work for us. The other aspect is, what about the cost, right? Personally, I mean, I look at it as does it meet the requirements? Does it reduce your support tickets of choosing the right antenna? And does it make your Wi-Fi users happy, right? Does it make good Wi-Fi? And in getting them that plan, right? So I try not to talk myself out of using antennas. I don't know. What do you guys think? What's your take on that?
Oh, people talk themselves out of it all the time. Cost, complexity of install, part count. A lot of folks struggle visualizing what the antenna patterns look like. I know
yes.
when I started,
Mm-hmm.
it was super, like I'd look at an antenna pattern and be like, is that what I want? I don't know. What about this other one? And it was really difficult to pick which one I would pick one versus the other. And so that if you're not comfortable with it, it starts becoming, well, it's just I can't make the decision, so put the integrated one up.
Mm-hmm.
Yeah, and that Echo certainly helps you get an understanding of visualizing the patterns in an environment. I know we used some directionals in a gym, but not on the ceiling. Oh crap! Sorry.
Please stand by.
The antenna is
Hopefully my
calling
wife will
you,
grab that
Steve.
That's
right
it.
away.
Antenna's
Until
calling you.
Yeah.
Got it.
Yeah.
Sorry.
There's
Well,
never a
that's
dull moment.
Never.
Yeah.
It's embarrassing. We put the directional at the end of the gym because that's the only place we could get the cable to. So you visualize that in
That's it. Yeah.
Echo, and
You would have to do it.
you can verify with an AP on a stick. You're not going to get a lot of loss through the water bags in the gym if it's up high enough. You're still shooting kind of down on them. But I tend to, like Jake said, you kind of, it takes some experience for sure to know when and where and what in terms of external antennas. But the best way to do it is to try it. I'm at the point now where I think I almost go to an external first, because we're not designing just for coverage anymore. I think 99% of wireless engineers are, capacity is going to be the first thing they need to think about. And you get capacity by reducing your cell size, and you can do that with external antennas.
Absolutely. So thinking about that, one thing, Jake, that you can leave the discussion with that you learned that has been critical to understanding how to pick the right antenna for you. And Steve, I'm going to ask you the same question, so be prepared.
Yeah, Steve.
Yeah.
We're quick, Steve. I think for me, there was a question about RRM in the Q&A, and I think for me, it was understanding that we talk a lot about how the APs hear the client, and how the clients hear the AP, but what we don't really talk about is how the APs hear the rest of the environment. And I think that when I started looking at directional antennas and I started playing with them and using them in my designs, I found that channel utilization went down. And the reason for that was just because the APs didn't hear the other cells, that might be fairly far away and might be fairly weak, but they didn't hear them near as well. And so, I went into a warehouse. It was all these Omnis up on the ceiling, and we went in. All we did was just change them to directionals pointing down, and the channel utilization went from like 60% channel utilization to like 10. And to me, that was like, I was like, oh, this is an important thing. It's not so much that, we did get benefits of the clients, but it was that how the APs hear each other was dramatically different and made a huge performance increase.
That is a huge difference. Cool. And that's like that's the blood pressure of your network, right? I think that's something that a friend of ours, George Stefanik, always gets on is that channel utilization is your blood pressure. And if you can look at that and see what it's doing, right? And you can see that from a spectrum analysis, right? Through a Sidekick, it's really cool to see, how is that actually affecting us, right? Looking at the tools and analyzing that.
Yeah. And okay, Steve, what about you? One thing that you can leave our discussion with that was the wow factor or thing for you what prompted you to start utilizing external antennas?
I think maybe not what prompted me to start using them. Like I came from an RF background before I got into Wi-Fi specifically. So antennas have always been like, I knew antennas before I knew networking, etc. So they've always been there for me. I think one thing to remember is not all antennas are created equal, regardless of maybe what the spec sheet might say. There's, manufacturing tolerances or manufacturing variations and things like that. I think more validation might be more important with an external antenna. Or at least testing. I think that would be my one thing to remember.
I think maybe then we could do some kind of follow-up API mistake validation of external antenna networks. And what do you do if the patterns don't match what your predictive was in that regard? Stu, maybe that's something that we can focus on.
And I'll be honest, I think I'm going to jump in. I think validation is important. I can't tell you how many times I've walked in and there's, I have some pictures of somebody deployed external antennas and they thought the little black rubber caps that were over the connectors were antennas. Or what was one? I had a coworker who they ordered the wrong pigtails. And so the APs were like RPT and C and the connectors were N, and they just like pushed the connector up over it and like Velcroed it in place. Like that doesn't really do it. And so, there more pieces means there's more things to go wrong. So validating does become exceptionally important.
Awesome. Yes, validating is definitely the key.
Your azimuths and tilts too, right? Those are with externals, those are going to be critical. Yeah.
So we're just coming up at the top of the hour. It's that we've had some really great content. And this is, I'm sure we could go an another half hour on this, but we covered a lot. We're not. No, we are at the top of the hour. But just to kind of summarize, I mean, we talked about concentrating RF, getting it where we wanted to get it to. We want to try to, understanding, reducing that co-channel interference by trying to shaping that RF. Reciprocity, that was the term of the day, is kind of how do we see that, try to increase the ability of the client's devices and increase the good and decrease the bad, as Jake put it. And I think that's there's some really great content on there. And as we're cupping up at the top of the hour here, and we kind of want to leave you with like, don't be afraid to use them, and use the softwares to get that, to understand what the pattern is doing, and do those predictive and post analysis, and even take an antenna apart. Take an patch antenna apart. If you've got an old one kicking around, I take one apart and have a look and see what engineering goes into those antennas. You'd be surprised at what a simple design it is. It looks like, but it's actually doing some pretty advanced stuff.
And so if you guys have any questions, feel free to reach out to Stu, myself, or if you have questions for Jake or Steve, that is on the screen. And I do believe that is all we have for you guys today. Thanks again, of course, to our esteemed guests, Jake and Steve, for joining us. Loved having you both as first timers on our Ekahau webinars. But please feel free to answer or to reach out to any of us with questions. We are going to download the Q&A from the chat. So thanks, folks. Enjoy the rest of your day.
Thank
or
you.
night.
And and we will end the recording now.